Sometimes two things that work pretty well on their own work even better when you put them together. For example, consider pie and ice cream. Each are a delicious dessert that you can enjoy separately, but when served together, the flavors of the hot pie and the cold ice cream complement each other so well that pie a la mode has become a popular dessert all over the world. In theory, the same concept can be used to combine the strengths of different green technologies so we can solve the climate crisis more efficiently. A perfect example of this is Bikers, also known as BECCS, which pairs bioenergy with carbon removal and storage. Let's take a closer look at both of these technologies separately, and then see why combining them might make an even bigger impact on carbon emissions. First, let's consider bioenergy. Bioenergy is based on one of the oldest forms of creating energy, burning biomass like wood and agricultural waste. Plants naturally absorb carbon dioxide from the air and sequester it. Therefore, if we grow certain fast-growing crops like switchgrass, corn, or bamboo, they will quickly absorb and store CO2 from the air. When these crops are burned for energy, they will not release any more CO2 than they initially absorbed. This emitted CO2 can then be reabsorbed by regrowing the crops, making this process a carbon-neutral way of creating energy. Next, let's move on to carbon removal and storage. One of the most appealing ways to permanently remove carbon dioxide is to capture it and store it underground in rock formations. We have the capacity to store an estimated 10,000 gigatons of carbon dioxide underground. That's enormous. If humans continue to emit CO2 at the same level we are today, we could bury all of it and not run out of room underground for at least 200 years. CRS is a carbon-negative technology, meaning that it removes more carbon dioxide from the air than it emits. However, the process of capturing carbon and burying it so deep underground requires energy. If that energy does not come from a renewable source, CRS runs the risk of being inefficient and costly. Bikers combines bioenergy, a carbon-neutral way to create renewable energy, with CRS, a carbon-negative process that requires energy. This way, the overall process is both based on renewable energy and carbon-negative, a total win-win for the environment. However, while this may sound great in theory, there are some drawbacks that are currently preventing us from applying Bikers in the real world. The first is a question of how scalable Bikers is, or isn't. Much of the fertile land that we would need to grow enough plants to make bioenergy viable is already occupied either by forests or farming. If we were to clear away forests for Bikers, we would be losing biodiversity and the tons of natural carbon storage capabilities of trees. If we infringed on farming land, we could be risking the world's food supply and negatively impacting local lives. Therefore, it is usually better to invest in forest preservation efforts to maintain biodiversity and develop ways to make farming more efficient. Bikers also emits carbon dioxide from other processes besides burning biomass, like harvesting crops, transporting the crops to bioenergy facilities, and transporting the captured CO2 to the sequestration site. If all of these emissions are not carefully calculated and balanced, Bikers may end up actually emitting more CO2 than it removes. Due to these challenges, Bikers is yet to be deployed at a commercial scale. Yet despite this, most climate scientists agree that Bikers will be essential to meeting our climate goals and are pushing for more research and development in this area. Bikers is one of the few technologies with the potential to remove the carbon dioxide that has been building up in our atmosphere over the past several decades, and we simply will not be able to meet our climate goals without it.